Hello guys, today we shall start new article, that is a perpendicular distance of a given point from a given plane. For that purpose we shall consider the equation of plane is Lx plus My plus Mz is equals to P. This is the equation of plane in normal form. That means L, M, N. These are the direction cosines of normal to the plane. Normal to the plane means a line which is perpendicular to the plane. And P is the perpendicular distance of this plane from the origin. Now we have to find the length of perpendicular from this plane of the point x1, y1, z. To obtain this, consider coordinate system, x-axis, y-axis, z-axis. This is the origin whose coordinates are 0, 0, 0. And suppose this is the given plane, Lx plus My plus Mz is equals to P. And this is the point P, x1, y1, z1. This is the given point. We have to find distance of this point from the plane, perpendicular distance. To obtain this perpendicular distance, we shall consider another plane which is parallel to the given plane. Suppose this is the one plane and other plane which are parallel. These two planes are parallel to each other. That plane and new plane which is parallel to the given plane passing through the point P. That means this is the other plane. Point is x1, y1, z1 which lie on the plane. And suppose that equation of this plane is Lx plus My plus Mz is equals to P1. And this is the plane Lx plus My plus Mz is equals to P. We know that if there are two planes which are parallel to each other, then there is a difference in constant term of their equations. Here constant term is P, here P1. Or P is the perpendicular distance of this plane from the origin. And this P1 is the perpendicular distance of second plane from the origin. Now draw the perpendicular suppose this point is K and K dash. The OK K dash is a line perpendicular to both the planes. Okay. Now this is a plane whose equation is Lx plus My plus Mz is equals to P. Now, point P lies on the second plane, and second plane is a parallel to the first plane whose equation is Lx plus My plus Mz is equals to P1. Now, here OK, that means distance OK is equals to, what is OK? OK is the perpendicular distance of the plane Lx plus My plus Mz from the origin. And by the equations given in normal form, therefore this P is the distance, small p is the distance OK. That means OK is equals to P. Similarly, OK dash is equals to OK dash means perpendicular distance of second plane from the origin, and by the equation of plane which is a small P1. Now draw the line PL which is perpendicular to both the planes, and therefore PL is parallel to K K dash. Because OKK dash is a perpendicular line to both the planes and PL is the distance between these two planes. PL is parallel to KK dash and we have PL is equals to KK dash. And therefore K dash is equals to OK dash minus OK. If K dash is equals to OK dash minus OK, but OK is P and OK dash is P1, this will become P1 minus P. But the point P, x1, y1, z1 lies on this plane. Lx plus my plus nz is equals to P1. As the point P lies on this plane, and therefore we must have L x1 plus n y1 plus n z1 is equals to P1. And therefore putting the value of P1 as Lx1 plus My1 plus Mz1, we take this as Lx1 plus My1 plus Mz1 minus P. This is a K dash. But K dash and PL are the distances between the parallel planes. And we have PL is equals to KK dash. That is, distance between these two parallel planes is given by Lx1 plus My1 plus Nz1 minus P. That means when we have given equation of plane in the normal form, and point is x1, y1, z1, then the perpendicular distance or perpendicular length of this point x1, y1, z1 from the plane is given by n into x1 plus n into y1 plus n into z1 minus p. Okay, this is a perpendicular distance when the equation of plane is given in normal form. But as we know that Lx, L, M, N are the direction cosines. If the equation of plane is in general form Ax plus By plus Cj plus D equal to 0. In this case, perpendicular distance of point x1, y1, z1 from this plane becomes, from this, using the values of L, M, N. L, M, N are the direction cosines in this case, and here A, B, C are the direction ratios. Converting direction cosines in the form of direction ratios, the equation of perpendicular distance becomes A x1 plus B y1 plus C z1 plus D upon square root of A square plus B square plus C square. This is a formula when the equation of plane is given in general form Ax plus By plus Cz plus D equal to 0. As in both the cases, it is a length. Therefore, it is always taken as a positive, and that's why we can take here plus or minus sign. If this value is negative, we shall consider negative. Negative, it will become a positive. Okay? You have to remember for MCQ these two formulae. For equation in normal form, length of perpendicular is Lx1 plus My1 plus Nz1 minus P. And for equation in general form, length of perpendicular of the point x1 y1 z1 is ax1 plus by1 plus cz1 plus d divided by square root of a square plus b square plus c square. Okay. As an example, we shall find a perpendicular distance of the point 2, 3, 4. 2, 3, 4. We have to find perpendicular distance of the point 2, 3, 4 from the plane 3x minus 6y plus 2z plus 11 is equals to 0. 3x minus 6y, 3x minus 6y plus 11 and 2z is 3x minus 6y plus 2z plus 11 is equals to 0. So this is the given equation and point is 2, 3, 4. Suppose this is a plane whose equation is given as 3x minus 6y plus 2z plus 11 is equals to 0. And one point is given. Suppose this point is represented by P, whose coordinates are 2, 3, 4. Then we have to find this perpendicular distance or perpendicular length. 3x minus 6y plus 2z plus 11 equal to 0. This is the equation of plane in general form. The point is 2, 3, 4, which is equivalent to x1, y1, z1, and a is 3, b is minus 6, and c, z, d, 11. Because general equation is ax plus by plus cz plus d equal to 0. Therefore, a is 3, b is minus 6, c is 2, and d is 11. And the for general equation of plane perpendicular distance is given by a x1 plus b y1 plus c z1 plus d divided by square root of a square plus b square plus c square. Okay. Now remaining part is only calculation. Substitute the values. This is equals to a x1. A is 3 and x1 is 2. That means 3 into 2 plus by1, that is plus b is minus 6 into y1. Y1 is 3 plus cz1. C is 2 into z1 is 4 plus b, that is 11, divided by square root of a square plus b square plus c square. Square root of, now a square is 3 square, 9 plus 36 plus 4, and this will become 2 3 are 6, minus 6 into 3 is minus 18 plus 2 into 4, that is 8 plus 11 divided by square root of 36 plus 4, 40 plus 9, it is a 49. This is equals to this 11 plus 8, it is a 19. Listen again, 11 plus 8 is 19 plus 6, it is 25. 25 minus 18. 25 minus 18 is 7 and square root of 49 is also 7. Therefore, the length of perpendicular is a 1 or 1 unit. Is it clear? Only we have write the formula, put the value and simplify again. Listen, 3 into 2 is 6, minus 6 into 3 is minus 18, then 2 into 4 it is 8 plus d, that means 11, 3 square plus minus 6 square plus 4, that means 9 plus 36 plus 4 it is 49, and 11 plus 8 it is 19, plus 6 is 25, 25 minus 18 it is 7, and this divided by 7 is equals to 1. This is the length of perpendicular of the given point from given plane. You have to write unit. Unit is not given here. Means you have to write 1 units. Whatever it is. Okay. By similar manner, you can find the length of perpendicular of given point from given plane. With this problem, we shall stop our today's lecture. Thank you.